Hi, my name is Erica, and today I'm going to be walking you guys through some derivative rules. To start, let's talk about what a derivative actually is. A derivative measures the rate of change of a function. You can also think of it as the slope of the tangent line to a graph at a point, as you can see in this graph. So when we take a derivative, we're measuring how a function is changing at any given input value. Moving on to derivative notation. There are a few common ways to write derivatives. If we have a function, f of x, let's say, its derivative can be written as f prime of x or dy dx. These notions all mean the same thing. Now we're going to move into a few derivative rules. The simplest derivative rule is the constant rule. The derivative of a constant is 0 because constants don't change. Next is the constant multiple rule. If a function is multiplied by a constant, we can keep that constant and take the derivative of the function itself, where it'll look like the constant c times f prime of x. Next, which might be the most important rule, is the power rule. If we have x raised to the power of n, the derivative is n times x raised to the power of n minus 1. In practice, we bring the exponent down and subtract 1 from it. For example, x to the third, the derivative of that function is 3x squared. Moving on to the sum and differences rules, derivatives distribute over addition and subtraction, meaning we can take the derivative of each term separately. So for f of x plus g of x, for example, the derivative of that is f prime of x plus g prime of x, and the same applies when you are subtracting. We use the product rule when we're multiplying two functions together, so f of x times g of x is equal to f of x times g prime of x plus f prime of x g of x. So again, the first function times the derivative of the second function plus the derivative of the first function times the second function. On the other hand, when functions are divided, we use the quotient rule. The derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. A cool trick I use to memorize this one is using low d high minus high d low over low low, where in this case f of x would be the high on the top and g of x, the denominator, is on the bottom as low. Next, we're going to look at exponential functions. So the derivative of e of x is e of x itself. However, if it was like e to the 2x, the derivative of that would be 2e to the 2x because you bring the 2 down. However, if we're looking at the constant, like a to the x for example, the derivative of that would be a to the x natural log of a. For the derivative of a natural log function, it would be the derivative of natural log of x is equal to 1 over x. When a function is made up of another function, we use the chain rule. The derivative of f of g of x is the derivative of the outside function evaluated at the inside times the derivative of the inside function. So for example, we have the natural log of x squared, which has two functions, natural log of x and then x squared. The derivative of this is 1 over x squared times 2x because the derivative of natural log is 1 over x, but that's x squared times the derivative of x squared, which is 2x. Finally, we're going to look at some trig derivatives. While I have not written down all of them, these are the most commonly used. So the derivative of sine of x is cosine of x, the derivative of cosine of x is negative sine of x, and the derivative of tangent of x is secant squared x. Overall, these rules let us compute derivatives quickly without going back to the definition each time and come up very frequently in calculus, so it is best to memorize these. But overall, I hope this video was helpful in helping you understand derivatives a little better.